Right, so tonight's session is looking at Intermediate Maths Paper 1 from the summer of 2017. We've set up the usual grade boundaries that we're going to aim for, looking at 40 marks for a C, 52 for a B. 40 marks pretty much takes us to the end of question 9. So I'll break this video clip when we get to question 9. We've pre-filled the extra formulae that are useful but we were required to learn, so trig's very unlikely to come up, but the more times we write it the better chance we've got of memorizing it. Our area of a circle, circumference and volume of a cylinder. Metric to imperial, more likely to come up on numeracy, but there's nothing stopping it being tested on maths, and speed, distance, time is the other relationship that we need to know. Okay, so let's get stuck straight in. Question 1. Write down the next two numbers in the following sequence. So when you're looking at a sequence, the first thing you need to do is to find out how the sequence is changing. This is decreasing. It's first of all dropping by 10, then by 9, then by 8. So the difference is changing by 1 every time. So this one will be a drop of 7, so that will have the value 1, and then this will be taking 6 off, which takes you down as far as -5. Part B, find the value of 2x plus 7y when x equals -3 and y equals 10. So when we do this in class, what I say is if you're replacing a letter by a number, it becomes a bracket. So the x breaks open and flies into a pair of brackets. So instead of x, I'm going to write -3, and instead of y in brackets, I'm going to put 10. Brackets tell us we multiply. So here I've got to do 2 times 3, which is 6, and the 2 is positive, the 3 is negative. If the signs are different, the answer is negative. Plus 70, 7 tens, and -6 plus 70 is 63. Part C, simplify means I want to look and tidy this up by gathering like terms. So I've got an 8k and I've got a -2k. Remember that each part of this has got 3 little signals. 1, whether it's positive or negative. 1, how big it is, its magnitude, its number, and the variable part of it, what's the letter. So that's plus 8k, don't bother writing that plus in. Take away 2, you end up at 6k. And then I've got plus 3m, take away 8m. So my number line, I'm starting at plus 3, I'm going down 8 steps, which will take me to -5m. So marks for that, just realised I'm writing in red.
That should be 64.
Yes, it should. First mistake of the day. 64. Okay, so there's 2 marks, 1 mark for 1, 1 mark for -5. There's 2 marks, 1 for getting it to -6 plus 70, so I would have got that mark. But then I would have lost the second mark, and then 1 mark here for 6k and 1 mark for -5m. Question 2. Write down 0.4, 15% and 7/20ths in ascending order. Okay? Ascending means going up, so from the smallest to the largest. And in order to do that, you need to get all of these numbers in the same format. So either all as decimals, or all as percentages, or all as fractions. Okay? Doesn't matter which you choose. But if they're all as fractions, they all need to have the same number on the bottom, the same denominator. If we decided to put them all as percentages, for example, the 0.4 to turn into a percent, I would times by 100, which would give me 40%. The 15% is already as a percentage, and then to get the 7/20ths, I would times that by 100 as well. So 1/20th would be 5, because 120 goes into 105 times. So it would be 5 times 7, which is 35. So that would turn them all into percentages. You could turn them all into decimals by writing 15% to 0.15 and then doing 20 into 7. But probably that's the easiest way. So now I can see that the smallest there is easy to compare because they're all in the same format. It's 15%. The next smallest is 35%, which is 7/20ths. And then the largest value is 40%, which was 0.4. So for that 3 marks, you get 2 marks for putting them all in the same format, whichever one you choose to do, and then 1 for the list of the original numbers. So those are those 3 marks. Question 3. So these are transformations. The trigger there is reflect. Reflect is like a mirror. So it has to tell you where to put your mirror. Now in the x-axis, well, this is the x-axis, so it's saying, imagine that you have a mirror running along there. Where will that reflection end up? And with a reflection, it ends up in exactly the same distance from the mirror on the opposite side. So that corner there is 3 squares above, so that corner will end up 1, 2, 3 squares below. That one will end up 3 squares below, but this one will end up 5 squares below. So the reflection that you draw will look like that. And just by turning it on its side, the human brain works nicely along a line of symmetry. So by turning that on its side, it looks right. You can see that that's the same distance. Part B, enlarge the triangle below by a scale factor of 3. So that means that my triangle has to become 3 times bigger in every respect. Now often they will give you a center of enlargement, okay? So they'll say from a center of enlargement wherever that may be, and then you have to count the distance from the center and enlarge that. With this one, you can draw it any way you like, so long as it fits on the page, because it's not giving you that center. It's just got to be 3 times bigger. So this vertical side is 3 squares, so in the enlargement it'll be 3 times 3, 9 squares. So let's start it there. 1, 2, 3, 4, 5, 6, 8, 9. Takes it to there. This 2 is going to become 6. And then join the rest of it up. So that they make enlargements harder by giving you a center of enlargement, so it's well worth revising that center of enlargement. Translate is the trigger this time. Translate means you're going to move it. Sometimes they'll give this as a vector. So rather than saying 3 squares to the left and 2 squares down, it's written like that for to the left and like that for down. So where this question is in the paper, it's part of the foundation tier overlap. They could put this in the second half of the paper in the higher tier overlap, and then it's more likely to be given like that, and that enlargement is more likely to have a center of enlargement. So 3 squares to the left. So if you choose a point on your original, so I've taken that, I need to move that corner 3 squares to the left, 1, 2, 3, and 2 down to there. The rest of the shape remains identical, so it doesn't change, doesn't turn, it doesn't become bigger or smaller. It's just there, and then I've got 4 squares. So translate literally means move, but keeping the shape the same. So marks for that. 1 mark for the correct reflection. For part B, 2 marks if you've got all the sides right, 1 mark if you've correctly enlarged one of the sides, and then 1 mark for correctly positioning that. Question 4. So on numeracy, no probability, which means they go to town on probability on the maths papers. So a fair 6-sided dice is rolled. What's the probability that a 4 is shown on the dice? Well, probability for a dice will be out of 6, and the number of times a 4 could come up is 1. So it's 1 out of 6. 50 raffle tickets were sold at the charity event. Sean has a 20% chance of winning the top prize. How many tickets did Sean buy? So a 20% chance, as far as a fraction is concerned, is that. And I want to find out how many tickets out of 50 she bought. So that would be 10. And then part C. The bag contains a mixture of blue beads, yellow beads and pink beads. 1 bead is taken at random from the bag. The probability that the bead is pink is 1/5. Which of the following sets of beads could have been in the bag? So what we need to do here is work out what the probability is for each of these bags of getting a pink bead. So in this first bag, it will be 3 out of 15. In this bag, it would be 5 out of 15, 5 out of 7, 1 out of 11, and 6 out of 15. Now, none of those is a 5th, but at least one of those is an equivalent fraction to a 5th. Okay, so if we take a look at the first one there, 3 out of 15, 3 divides into both of those numbers. 3 goes into 3 once, and into 15 5 times. So that bag, although it's got 3 out of 15, is equivalent to a 5th. So that's the bag. So marks for that, 1 for each. So they're either right or wrong. Question 5. So we had a similar question yesterday to this, where it was to do with flower pots. This one now is about 2 teams. So Team A and Team B play in a competition. So A, B. Team A has 9 more points than Team B. Team A has 4 times as many points as Team B. So both of those conditions are met depending on what B is. So if we try, if B has got 1 point and Team A has got 9 more points, that means Team A has got 10. But that value is also 4 times that. And 4 times B is not 10. So it's not that one. So we try 2. If B is 2, A is 9 more than that, which is 11, but 4 2s are 8, not 11. So that one doesn't work. Try 3. If B is 3, A has got 9 more than that, which is 12, and if I times 3 by 4, I get 12. So that arrangement is the correct one, where B has got 3. Is something flashing? Me. So B has got 3. If I add 9 to 3, I get 12. And if I times 3 by 4, 4 times as many, I also get 12. So 2 marks if you got both of them. 1 mark if you got one that satisfied one of those conditions. Question 6. David, Jane and Mary are beach inspectors. 3 beaches, Harlech, Rill and Porthcawl, are all to be inspected on a certain day. It's decided to share the work so that the inspectors will visit 1 beach each, chosen at random. List all the possible different ways. So when we did this in class, I was banging on all the time about being systematic in how you do it. Okay? So 1 has been done for you. Well, let's write that one out again, just so we remember to count it, and I'll explain about that in a moment. So David to Harlech, Jane to Rill, Mary to Porthcawl. We keep this fixed and switch those. So David is still in Harlech, but this time Jane is going to Porthcawl and Mary is going to Rill. The next one, now I need to change David because he can't go to Harlech again. So I'll take David to Rill, Jane to Harlech, Mary to Porthcawl. But while David's in Rill, Jane could be in Porthcawl and Mary could be in Harlech. David now has to change from Rill, so the only place he's got left to go is Porthcawl. So David could go to Porthcawl, Jane could go to Harlech, leaving Marie in Rill, or David could be in Porthcawl, Jane could be in Rill, and Marie could be in Harlech. There's no other arrangements there could be. So there are 6. What is the probability that one of the female inspectors, so Jane or Mary, will visit Rill? Well, Jane could visit Rill or Mary could visit Rill. So there are 2 or Jane could visit Rill or Mary could visit Rill. So there are actually 4 different ways where one of the inspectors is visiting Rill. So that's 4 out of 6. Now, the reason that I rewrote the David, Harlech, Jane, Rill, Mary, Porthcawl myself was so that I had all of them in my handwriting, because a really common mistake is when you're counting them up, you only count the ones that you've written and you've forgotten about the printed one they've given you. So if you're likely to make that mistake, write that one out yourself so you know you're counting your handwriting. Marks for that, 2 marks for the listing of the figures, 2 marks for this, 1 mark would be for the correct number on top, and 1 mark for anything that's out of 6, so long as it's less than 6. Question 7. ABCD is a quadrilateral. Okay, I can see here I'm working with angles. So the angle fact I need to know about quadrilaterals is their interior angles, the inside angles, add up to 360 degrees. So quadrilateral adds up to 360. Calculate the value of x. So I know that I've got 3x and 2x and that 1x up there and that, and I need to know that that box means 90. Those 4 angles have to come to 360. Now I can simplify it because I got a 3x and a 2x makes 5 and 1 is 6x plus the 90 equals 360. So rules of equation, I want to get the x on its own. First thing I can do is get rid of that 90 by taking it off. If I take it off that side, I have to take it off the right hand side as well. This will leave me 6x on the left hand side and 270 on the right hand side. To get the x on its own, I have to divide by 6. If I divide that side by 6, I have to do the same over here. So that will give me x equals. It's a non-calculated paper, so if I don't know how many 6's there are in 270, I've got to go and work it out. 6 into 2 doesn't go. 6 into 27 goes 4 times. 4 7s are 24. Carry 3. 6 into 30 goes 5. So x is 45 degrees. You need to read the question with these types of challenge because sometimes they'll ask you to find the value of x. Other times they'll ask you to work out how big each angle is. This time it's just x. But for part B, when ABCD is drawn to scale, would the lines AD and BC be parallel or not? You must justify your answer without using a scale drawing. Now, very few kids picked up marks on this in the intermediate tier because they said, well, just looking at it is obvious because they're not parallel, there's no arrows on it. But that's not what they're asking you to do because it's not drawn to scale. So if I know x is 45 degrees and I've got two x's there, that means that that angle is 90 degrees. 90 degrees is a right angle, and so is that, which means they are parallel. So because 2x equals 90 degrees, so by drawing it on the graph, it would be the easiest way to do it. Okay, so as long as I see that 90 up there, I'll just check with the mark scheme. Yeah, so 2x is 90, so angle A and angle B are both 90 degrees. Okay, but annotating that again is clear what you mean, so long as you see that 90 there. So the marks for that one, there's a method mark for forming your equation. So either writing the whole list down or by going straight to 6x plus 90 from adding it up on the diagram. Then there's an answer mark for getting it down to 6x is 270. One mark for dealing with the 270 divided by 6, and one mark for the 45 degrees. And then for part 2, one mark for working out 2x is 90 degrees, and one mark for showing or explaining why that is as it is. Okay, question 8. Estimate is the trigger here. It means you haven't got to do any bonkersly difficult maths. You round to one significant figure, generally. So 41.3, I'm going to round to 40. 29.6, I'm going to round to 30. And 198.7, I'm going to round to 200. Work out the multiplication on top. 4 3s are 12, followed by 2 zeros, over 200. I can then divide repeatedly by 10 until I run out of zeros, and 12 divided by 2 is 6. With a question like part B, it's a combination of estimating and using the information they're giving you. So if you know that 54 times 84.2 is 4546.8, and in these questions, 2 sets of digits are the same, whatever one is missing is going to contain the digits of your answer. So that one matches the 54, that one matches that, so my answer is going to contain these digits. I just need to know if and where the decimal point goes. So 540 times 842 is roughly 500 times 800, which is 5 times 8 is 40, followed by 4 zeros. So I've got 1, 2, 3, 4, 5, 6 digits in my answer. 1, 2, 3, 4, 5 digits. So I need to add a 0 to make that of the right magnitude. With the second one, I've got the 4546.8, which is that bit, and the 54 there. So this one is going to contain the digits 842. On top, I've got roughly 5,000. On the bottom, I've got roughly 5. How many times is 5 equal to 5,000? 1,000. So 842 is close to that, so there's no decimal point to go in. This version, I've got the 454, I've got the 84.2, so it's going to contain the digits 5 and 4. On top of that division, I've got roughly 500, and on the bottom of that, I've got roughly 100. 500 divided by 100 is 5, so to make that close, I put the decimal point there. So marks for that, 1 each. Oh, on the top, a method for correctly rounding to one significant figure, and an answer, and then 1 for each of those. And then question 9. Here we go. Here's our trigger. This is where they're interested to see how you organize your work. In the diagram below, ABCD is a rectangle. ABCD is a rectangle. And PQ is parallel to AD. So because that's parallel, it means it's basically cutting it into 2 rectangles. The area of ABCD is 52 square centimeters, and the area of APQD is 20 square centimeters. So calculate the values of F and G. So the area of ABCD, so the area of the whole rectangle is 52, and the area of APQD, this bit, is 20. So if I know the whole rectangle, and I know that rectangle, then by subtracting, I can work out the area of that rectangle. So that rectangle is going to be 52 less 20, which is 32 square centimeters. So now we're into a reverse area. I know that this rectangle, area of a rectangle is length times width. So for PBCQ, the area 8 times F actually is 32. So F, I would divide both sides by 8. 32 divided by 8, 4 centimeters. So I now know that that is 4 centimeters. If BC is 4, PQ is 4. Because they're parallel. So now, for this rectangle, APQD, 4 times G equals 20. 4 times something is 20, the something is 5 centimeters. So F is 4 centimeters and G is 5 centimeters. So there's 5 marks for the maths. There's 1 mark for the 32, for taking the 2 areas away. There's a method mark for 8 times F is 32, and an answer mark for 4 centimeters. And then there's a method mark for 4 times G is 20, and an answer mark for 5 centimeters. And then your OCW, 1 is for just being organized. Annotating your diagram is fine. Okay, so putting that up there is part of your organized work, and then separating out 2 rectangles and a conclusion. And then the other mark is for consistent units, area centimeters squared, lengths centimeters. So that takes us comfortably beyond 40 marks. We'll take a quick break there.